Now the next couple of examples of radical equations that we're going to look at will be equations that will contain more than one radical term. And so for this example we have 5 times the square root of 4y minus 1 minus 3 times the square root of 10y plus 25 is equal to 0. Now as our first step, what we'd like to do is to isolate one of the radical terms. So what I'm going to do is to add 3 times the square root of 10y plus 25 to the other side. So we'll have next as our second step 5 times the square root of 4y minus 1 is equal then to 3 times the square root of 10y plus 25. Now if we wanted to completely isolate the square root on the left hand side, what we could do is divide both sides by 5, and you will see that approach when you look at the solutions to some of the U-triads that come after this. But I'm going to show you a little different way that you might like a bit better, or at least think of it as an alternative. What we're going to do now is to actually square both sides of the equation in the form that we see. Now, when we square the left side, you want to be careful to be sure that you square both the 5 and the square root expression. So when we do that, we'll have then 25, and then squaring the radical will produce then just 4y minus 1. And in a similar way on the right hand side, when we square, we want to be sure we square the 3 first, which will produce 9. And squaring the radical will give us 10y plus 25. So in this case, we were able to eliminate both radicals by squaring both sides of the equation. So now we'll continue in the usual way. So we'll distribute on the left-hand side the 25. So we'll have then 100y minus 25. And on the right-hand side, distributing the 9, we're going to have 90y plus 225. So moving the 90y to the left-hand side, we will have 10y. And adding 25 to both sides, we will have then 250. And so we end up then with a possible solution of y being equal to 25. Now remember, it's crucial and imperative we check the solution back in the original equation to see if it's going to be a valid solution. So we'll do that next. Now checking the possible solution of 25 back into the original equation, you'll note that I've written the original equation first, and then I have substituted the 25. Each place the y occurred in the original equation. And so what we'll do now is to carry out the simplification. So we have then 5 times the square root of 100 minus 1 minus 3 times the square root of 250 plus 25 is equal to 0. Then going back to the first term, that becomes 5 times the square root of 99. Then minus 3 times the square root of 275 is equal to 0. And now we want to look for perfect square factors in each of these radicals. And in the 99, there's a perfect square factor of 9, so we can rewrite that then as 9 times 11. And 275 has a perfect square factor of 25, so we can rewrite that as 25 times 11 is equal to 0. Now going back to the first term, the square root of 9 will come out of the radical as 3, and then multiply by the 5 in front will produce 15 times the square root of 11. And in the second term, the square root of 25 will come out as 5, and multiplied by the 3 in front will give us 15, then times the square root of 11 equal to 0. And you can see that we have like radical terms, and adding them together we end up with 0 is equal to 0. So it looks like the possible solution of y equals 25 does indeed check. So we can state then officially that the solution to the equation is y equal to 25.